This lesson will be on 11-3, multiplying rational expressions. When multiplying rational expressions, we'll be multiplying fractions. In order to multiply fractions, we'll multiply our two numerators, then we'll multiply our two denominators, and then we'll reduce. So, when multiplying our two numerators, we have 5ab to the third times 16c to the third, which will give us 80a b to the third, c to the third. In the denominator, we have 8c squared times 15a squared b. 8 times 15 is 120, and we have an a squared, we have a b, and we have a c to the second power. Now we can reduce. 80 over 120 becomes 8 over 12. 8 and 12 can both reduce by 4. 4 goes into 8 twice. 4 goes into 12 3 times. Now let's look at our variables. We can reduce our variables as well. An a crosses off on the top with an a on the bottom, and we'd have one a left on the bottom. A b crosses off on the bottom with one b on the top, so we would have two b's left on the top. Two c's will cross off on the bottom, as well as two c's on the top, so we'll have one c left on the top. So our final answer is 2b squared c over 3a. A second way of doing this problem. Remember that when multiplying fractions, we can always reduce first. So if we take our original problem and we reduce this first, 16c to the third, 15a squared b. We're going to reduce this first. So 5, any number on the top can reduce with any number on the bottom. So 5 and 15 can reduce. 5 goes into itself once, 5 goes into 15 3 times. Now a number on the bottom can reduce with a number on the top. 8 goes into itself once, 8 goes into 16 twice. So right now, in our answer, for our coefficients, we have a 2 on the top and a 3 on the bottom. Now let's look at each of the variables. We'll start with a. We have an a on the top, which can cross off with one of the a's on the bottom. So we'd have an a left on the bottom. B's, we have a b on the bottom here. We also have 3 b's here, so one will cross off in each spot, and we'll have 2 b's left on the top. Last, c's. We have 2 c's here that we can cross off, and we can cross off 2 of these c's on the top here, so we'll have a c left on the top. As you notice, we get the same answer. So we can either multiply, like in example 1, and then reduce, or we can reduce as our original work, as in example number 2. In example 1a and 1b, should be a 1, we'll be simplifying our rational expressions again. So let's start with 1a, and let's reduce as a means of simplifying. We'll start with our coefficients. 5 and 10 reduce. 5 goes into itself once, 5 goes into 10 twice. And these are our only coefficients, so we'll have a 1 on the top of our answer and a 2 on the bottom. Now let's look at c's. We have 3 c's here and 1 c here on the top. So we can cross off 4 c's on the top with 4 c's right here on the bottom. We do, however, have 1 c left on the bottom, right here. Now for d's. We have a d on the top right here, which can cross off with this d on the bottom. Then we'll have 3 d's on the top left over. Now for f's. We have 2 f's on the top and 4 f's on the bottom. So 2 can cross off in both spots, but we'll have 2 left on the bottom. Example 1b will be reducing as well. So let's look at our coefficients first. We have 16 on the top, 3 on the top, 8 on the bottom, and 32 on the bottom. We can reduce the 16 and the 8 or the 16 and the 32. Let's start by reducing the 16 and the 32. 16 goes into itself once, 16 goes into 32 2 times. Now we have a 1 and a 3 on the top, which is 3. On the bottom, we have an 8 and a 2, which is 16. We should be crossing those out so that we know we're done with them. Now, let's look at each of our variables. It helps if you go in order when you do this. So let's look at our g's first. We have 2 and 2 g's on the top, so we have 4 g's on the top, but only 1 on the bottom. So we can cross 1 off on the bottom with 1 off on the top. If we had 4 on the top and we cross 1 off, we're only going to have 3 left on the top. Now for h's. We have 3 4 h's on the top and 2 3 h's on the bottom. So if we have 4 h's on the top and 3 on the bottom, we can cross off 3 in both spots. But we had 4 on the top, so we'll have 1 left over. Last, we have j squared on the bottom with no j squares on the top. So we'll have a j squared left on the bottom. In example 2, we'll be simplifying the expressions involving polynomials. When doing this, we'll need to factor each of our numerators and each of our denominators. X minus 5 is factored completely. X squared would break up into 2 x's. We don't have to break that up. On the bottom, we have an x, and then our other denominator, x squared minus 2x minus 15, factors into 2 binomials. Remember, when factoring this, we're looking for the factors of 15 that subtract to give me a negative 2. Well, the factors of 15 are 5 and 3. In order for me to subtract and get a negative 2, I'd have to have a negative 5 and a positive 3. And now we can start simplifying our expression. We can reduce any variable with any variable that is not in an expression. So this x in our denominator can cross off with one of the x's here in our numerator. This will mean we'll have 1x left over. We can also reduce any expression with any like expression. So for instance, we have an x minus 5 as an expression in our numerator, which can reduce with an x minus 5 in our denominator. Everything left over gets multiplied back together. So on the top, we have an x left over. On the bottom, we have the expression x plus 3. This is our answer. Example 2a will be done the exact same way as example 2. We'll factor each part of our numerator and denominator. So we have x plus 3 over x times 5 over, now x squared plus 7x plus 12 will factor into 2 binomials. We're looking at the factors of 12 that add to give us a positive 7. The factors of 12 are 2 and 6, 1 and 12, or 3 and 4. We're looking for the ones that add to 7, which would be a positive 3 and a positive 4. Now we can start to reduce. Remember that you can reduce any variable or number that's not in an expression with another variable or number that is not in an expression. So we would try to reduce this x and this 5. However, we can't reduce them. You can also reduce any expression with any equivalent expression. So our x plus 3 in our numerator will reduce with our x plus 3 in our denominator. Our final answer will be everything that's left over, multiplied together. So we have a 5 on the top in our numerator. We have an x in our denominator. we also have an x plus 4. This is our answer, 5 divided by x times x plus 4. Example 2b will be done the exact same way. Let's factor everything in both our numerator and our denominator, and then let's reduce. So, in our numerator, y squared minus 3y minus 4 factors into y minus 4, y plus 1. Negative 4 times positive 1 gives us a negative 4. Negative 4 plus 1 gives us a negative 3y. Here we have y plus 5. And then in our denominator here, this factors into y times y minus 4. Remember that you're just taking out a GCF of y. Now we can reduce. Let's look for expressions that can be reduced together. We have a y plus 5 in the numerator with a y plus 5 in the denominator. We have a y minus 4 in our numerator with a y minus 4 in our denominator. So on the top we have y plus 1, and on the bottom we have y. This is our final answer. Remember that you cannot reduce the y in y plus 1 with the y in your denominator, because one is in an expression and the other is not.